going to talk today about domain and range. Before we get into the math, I want you to keep in mind your domain is where you live, where you started out. Okay? Usually that's your home. Your range is how far away you go. You know, home on the range. How far out there can you get? Okay? And so those are the places that you go to in your life. When we talk about that in terms of functions, the domain is almost always our x value, where we start. Our range is almost always our y value, where we end up after we have done something to our numbers. Okay? So just so you have kind of a connection to things. So they're calling it the input, that's not what I wanted to highlight. Never mind. Never mind. They're calling it input and output. So they're saying, that is kind of what I wanted to highlight. Inputs are domain. I'm sorry. I should have stayed in bed. And output is range. Okay, so your answers. Inputs, what you're starting with. Answers, what you're getting out. So let's start with number one. We have a function that has its inputs as the months of the year. And its outputs are the number of days in each month. And for our purposes, we're going to assume that it's not a leap year. Okay? I know. Because it tells us that we're going non-leap years. Okay? Alright, so in roster form, which is just this, what is the set that represents the function's domain? In other words, what are the names of the months of the year?
Ooh, that's a hard one.
January, February, March, and April, May, June, and July, August, September, October, November, don't forget December at the end. Okay, now you certainly can write them out if you want to, but I would assume that you don't want to write any more than you have to, so we're going with letters. In roster form, what is the set that represents the range? And I will admit that I had to do the 30 days, has September, April, June, and November. All the rest have 31 except for February. I had to do that several times to get through this, so I'm not going to do that again. January is 31, February is 28, March, April, May, June, July, August.
Why do we have such screwed up ones?
I wish we just had like 30 days every month. It'd be a lot easier than that.
That's it, domain and range, input and output. So you know what month, if you know what month you're in, then you can tell what your outcome is.
Yeah.
Keep your opinions to yourself. Thanks. Okay, number two. The range of the function and its domain is 1, 3. So the domain is 1, 3, and 5. We're going to function those numbers. We're going to do the 2n plus 1 deal to them and get the range to get the answer. So what is the range? So 2 times 1 plus 1 equals 2 times 3 plus 1 equals, and 2 times 5 plus 1 equals, and that's our range. Nope. Nope. And then we can look at domain and range in terms of a graph. So we have some beautiful function here. What are the minimum and maximum x values? So here's our x-axis. What is the minimum and the maximum? So in other words, how far over do we go? Our lowest value and our largest value on the x-axis.
-3.
Yep. Now, we're big boys and girls now, so our x's are from -3 to 6. And they are inclusive. So they have an equals to with them. Yep,
How do you read that?
I read it, x is between -3 and 6.
Oh.
Okay?
Wouldn't that be saying that not equal to?
X is greater than, this says, x is greater than or equal to -3, and x is less than or equal to 6.
Oh.
Okay?
No, wait, no.
All right?
Where are you at?
Okay. Letter B, we're gonna do the same thing with our y values. So it's our minimum y and our maximum y.
5, and 4.
I agree. And I would read that y is greater than or equal to -5, and y is less than or equal to 4. Or y is between -5 and 4. Letter C wants us to say the domain and the range using set builder notation. It's been a while since we've seen set builder notation, but we did it in algebra last year. So, let's start with the domain.
The train's going by and they're doing work on the railroad, it's not finished.
I was thinking the same thing, but it must be okay.
I hope so, otherwise I'm gonna hear really loud crashing.
So if we hear really loud boom bang,
That's
they,
awesome crash.
they're testing it out.
I wouldn't be
I'm
that
not-
maybe home, but.
I'm not afraid all the way over here, but.
Was it closed or something?
Well, I mean, you got.
Yeah, they're
Yeah,
Very
they're
One
much.
going
train
Very
wheel
much.
comes down like a final destination just for
I
him.
mean, those ones that,
This morning.
They're
they're
all
still in
three.
Albertville.
Starting tomorrow, it's the
Over the train wreck.
Knights Creek one. You're gonna have to go around by the post office and come over the tracks that
they
way.
just about eat the motorcycles, those.
Just one.
Yeah, they shouldn't now. Okay, so, still waiting for that loud crash. I don't hear it.
See, oh, it's not the train just stopped.
Let's just pretend that everything's fine.
Alright,
So X such that, no wait, we use the dots. I
this
lied.
morning they started a lot of work.
That's it, that's set builder notation for domain. So just our answer from letter A. And our range for the y values. And again, it's our answer from letter B. Whoops, I got a little carried away with my bracket there at the end. One of my,
No, I don't even, I can't even do those.
one of my algebra kids calls these mustaches. Can I just draw a mustache, Mrs. Inslee? Sure. Sure you can.
What kind of mustache?
They're hard to draw, really.
They are a little tricky. So domain and range, we can see it in the terms of a roster where you just list them all off. You can see it in terms of, this is called a mapping. What we did here in the middle, it's called a mapping. And then down here at the bottom, we can talk about it in set builder notation. So we have lots of different ways to represent domain and range. To the back.
I feel like I'm not gonna be able to do a lot of this.
Oh, you're doing fine.
Mostly multiple choice.
Boom.
Yeah, okay, so sometimes we get into this little issue where we have arrows on our functions. What'd you say, Bruce? Infinity, yep, that's absolutely it. If you notice in our answers here for number 3, we have some infinity symbols. Infinity is just a sideways 8. You're certainly welcome to turn your paper and make an 8 and then turn your paper back so your writing is sort of still normal.
So that's a bow tie.
Yep, oh, a bow tie, very nice. Okay, good. So here's our function, it's a parabola. Which of the following represents the domain and range in interval notation? Now remember, for interval notation, if we have the square bracket, then it is inclusive. And if we have the parentheses, then it is exclusive. Yeah? So in other words, inclusive is gonna have an equals to. Exclusive is just going to be the greater than or less than. Okay, so the inclusive will be an equals. And I'll tell you right now that infinity is always an exclusive. It's always a parenthesis when we go to infinity. And even if we go to negative infinity, it's always a parenthesis. Because in theory, you can't count to infinity. In theory, there's no value that's actually infinity. Okay? So that's why the parentheses are there as an inclusive.
Infinity minus 1,
Excuse
infinity
me.
minus 2.
Excuse me. Let's talk about domain. What are my x values for this parabola?
Yeah, negative infinity by infinity.
Negative infinity to positive infinity is our domain. Because we can put any number in there and we'll be able to get a range. But does this range go, in number 3, go with our domain? In other words, are we down here at -4? Bless you. Is this -4 in our y's, and do we head up to infinity in our y's? Yes, we do. So choice number 3 is the correct domain and range for this graph. We can, of course, use our handy dandy calculators. They've given us a picture of one here in number 5. From the table, can you find what the value of f of 1 is? So you're going to take a look at that x value of 1 and go across. And in this function, we get a range or a y value of -1. Can you do f of 6? And again, you go to 6 for your x's and look across, 6.5. Okay? Sorry? Thank you. Letter B, why are we getting an error here at x equals 4?
Because it's infinite.
No.
Yes? Well, if you look at
No.
it. Okay.
Thank you. It's an asymptote, which is not the same as infinite. Thank you. We get an error at x equals 4 because what happens if we put an x into that denominator?
I don't know what the answer is.
What is 4? Take away 4, Carolyn. I think you know that answer. Yeah. And can we divide by 0? That's why we have the error.
Then how are they showing it on this graph?
Because they're showing it as an asymptote. This line is an asymptote. Hey, have a great night.
Well, the videos on the password.